So we know what is the unit now. We know how do we calculate DPU, total number of defect by total population. Population is total number of units inspected. Opportunity we know, right? And then there is, we need to calculate total opportunity. And then there is something known as DPMO. Okay, and we will explore this CTQ and USL, LSL later on. So right now we'll just limit our calculation to DPU, DPO, and DPMO. Okay, we know for a process to be working at a 6 sigma level, we should be creating only 3.4 sigma, 3.4 defect per million opportunity. How many defect are we creating here per million opportunity in this example?
100,000 per million.
100,000 per million. So what do you think, sigma level would be higher than 6 sigma, lower than 6 sigma, or you're somewhere near 6 sigma?
Lower.
Lower, probably 0.
Somewhere negative.
Right, somewhere negative, absolutely. Because what we are saying is, for every opportunity, 10% is the defect rate that we have. Right, so with is quite high, right?
Correct.
So just so that we understand, let me just give you a scenario. Unit. So let's say we inspected 40 units. We have defect which is 4. Opportunity per unit, let's say 10. So can you calculate DPU, DPO, DPMO, and give me a rough approximate sigma? In approximate, you can just tell me if it is higher than 6 or lower than 6.
Yeah, let's see what we can do here. 44 and 10. So DPU per defects per million. So defect DPU would be 10%, 0.1.
Okay.
40 divided by, or 4 divided by 40.
4 divided by 40, right?
Right. DPO per opportunity would be, there's 10 opportunities, so 4 divided by 10, 0.4.
0.4. Okay, let's see. Total number of defects that we have is 4 divided by total number of units.
Oh, okay, I did that wrong.
Remember, total opportunity, 0.01.
So it's total units times opportunities.
Because this is opportunity per unit.
Okay. Okay.
Okay. How much is DPMO?
That would be equal. That times 10 times a million, right?
Yep.
Is that right? So it's still, it's 10,000?
Yep.
Right. Okay.
So in terms of sigma level,
the sigma level is,
I'll take you to slide.
Is there a calculation for sigma level?
Yes, there is. We'll go through that later on. We'll go step by step.
So 3.5, 3.8, somewhere in there?
Yeah, somewhere between 3 to 4, right?
Okay. Yeah. Right.
Okay, how about scenario B? So this is a point where I get to rest.
41. All right. So scenario B, we're going to go 4 divided by 40. Still the same 0.1 because we didn't change anything there.
Absolutely.
And then this one's going to be 4 divided by 1 times 4, right? Oop, go back, times the 40. It is 0.1 as well? Okay.
Yep, because there's only one opportunity per unit, so denominator remains the same.
Right. So that will increase our defects to 100,000.
Right.
Okay.
Defect per million opportunity 200,000.
Mm-hmm.
All right. So this is how we would generally calculate where we have the defect count. When we are dealing with the count. So we will understand in the training, further that how do we, know when to use this method. So there are various ways of calculating process capability, the sigma level. So one is this method, which is DPMO. Other one is known as Z calculation, right? So how do we know which one to use? It will depend on the type of data that we have. So we will understand, what are the various data types and how do we calculate, this the sigma value. Okay, let's try and understand the concept of. I was planning to cover it after define, but then since we have started this, let's try to cover the concept of that. So for any kind, let me just see if I have it somewhere in the slide. Okay, I don't have it there. So any data that we have, let's try to do some data analysis. Let's try to understand, how would we analyze any data. So any data set that you have, there would always be two way of looking at any given data set. Let me just use the slide. Okay, so any data can be looked at from two aspects. So one would be able to see the slide where I'm writing, right?
Mm-hmm. Yeah, I can see it.
Okay. Measure of central tendency. And second way of looking at it would be measure of dispersion. Let's understand what is central tendency and what is dispersion. So any idea about this? What is central tendency and what is dispersion?
I don't.
Okay. So central tendency is that one point in the data set, which tells us about the entire data. So let me just try and explain. We use average a lot, right?
Right.
We say on an average, how much is the per capita income of a country, or how much on an average, how much is the money that people at a certain designation make. So we use average a lot, right? So what is average? Average is that one number which is telling us about the entire data set, which is representative of the entire data set, right? So that is basically one of the measure of central tendency. So we call it mean or average. And there is another way called median, and third way called mode. You heard about mean or average?
Correct. Yep. I'm good with that one.
Okay. You would have definitely heard about this, but let me ask you: do you remember median?
Median and mode I struggle with. How about that?
Right, right. So I think we might have covered it in our bachelor's or during our school days.
Mm-hmm.
So probably I'm taking you back to the 8th or 9th standard when we would have covered this median. Median is the middle value. So let's say, let's say this is the data that we have.
That makes sense.
So in this, let's try and calculate everything. Let's try and calculate average. So we know how to calculate average, not on Excel, but otherwise you add everything, divide by the count.
Right.
So 1,
Yep.
2, 3, 4, 5. So sum of everything, which is 231 divided by 5.
46.2.
Will give us 46.2. Or we have Excel, so we simply write in the formula, select the range, enter 46.2.
Mm-hmm.
Yep.
Yep.
Is the average. So if it is the data for, let's say, average handling time of the call in the company that you're working in, so you can pretty much say that on an average the average handling time is somewhere about 46 minutes in the organization that I'm working in. So you would be about right. Correct?
Mm-hmm. Correct.
Second is median. So how do we calculate median? There's a way of doing it. So to calculate median, first you would need to arrange the data in ascending or descending order. Okay, so
yep, makes sense. 34, 45, 47, yeah.
Oh, so I have.
Yep.
I've done it in descending. So we have 1, 2, 3, 4, 5 values. 47 is the middle. It's the middlemost value. So 47 becomes median.
If it's an even number, you take an average of the middle?
Yes, absolutely.
Okay.
So let's say if it would have been 24 here, so you would take both of these, average of both these
46
would give you median.
Yep. Okay.
Right?
Got it. Yep.
Another way of calculating, Mr. Excel, to our advantage or benefit, we simply do that, it'll calculate. So if you remove it out, it'll give us 47. Yep, good with it?
Nice.
Mode is the most frequently occurring number in a data set. So if there's any number which is occurring more than 1, unfortunately or fortunately, we don't have any mode here. So mode is the most frequently occurring number in any given data set. So we don't have any mode here. We can calculate average or we can calculate median. Okay,
that makes sense.
Right. So what is median or what is average? It is one number that is telling us about the entire population. Okay.
Yeah.
So we have done a lot of trainings. In fact, there's one organization where they do the entire day training, entire 8 hours of training. And the topic is why mean is bad, right? So,
Okay.
And unfortunately, we use average a lot. We use mean a lot. So before I
All the
actually
time.
studied Six Sigma, all the time, nobody would ask you, what is the median salary or what is the median this, right? Everybody would ask you on an average. You tell me on average, how much you make, or on an average, how much does it cost, right?
Mm-hmm.
So looking at mean, I'm not saying it is always bad, but I would say looking at mean alone is bad. The reason why is because mean gets influenced by too high or the too low values. Let me explain it to you with an example.
Yep.
So what happened some time back, or rather I would say a long time back, there was a study conducted in London. And what they were trying to do, they were trying to calculate the household income of people living in a particular locality. The reason was, the intention was that government wanted to take a decision whether they would need to give subsidies to people living here, or they would need to impose taxes. And they wanted to take a decision basis their household income. So they did F and G. Okay. So what they did, they calculated the income. So it'll be, so they went to the first household, they gathered how much money um, that particular household makes. So it was somewhere about £2,000. They went to household B, it was somewhere about £1,900. Household C, 2,100, 2,200, 1,800, 2,000, 2,000, like that. Okay. So this is the data that they collected. Okay, so we always calculate, average, right? So somebody asked them, on an average, how much, people living in this particular locality made. So they calculated average, which in this case would be somewhere about 2,000. Rather, it will be 2,000. So average or mean income
Mm-hmm.
came out to be £2,000 per month. Living in London, it's an expensive city. £2,000 is not enough. It's not, very high, not even close to decent. So, government said, no, people living here, we need to support them. So, what they started doing, they started giving subsidies to people living in this particular locality, basis this data that they collected. Okay, so so that people can meet their ends and people can live a decent life. They're able to meet their expenses and all that, basic amenities they're able to purchase and all that. So it was going on well. Time went by, about 1-2 years. There was a change in the government, and what they said, let us go back and revisit the data here. So what they said is, they picked up this particular locality, let's say, and they said, let us collect the data again and see if there has been any changes, whether we still need to give subsidies to people living in this particular locality. So they collected data, it became 2050, it became 1850, it became 2000, it became 2100, it became 1900, and it became 1950, something like that. Something happened here in household G.
Mm-hmm.
Okay, so you know who Lakshmi Narayan Mittal is?